Magandang hapon po sa lahat ng dumalo. Thank you so much for joining us this afternoon. I am Tonetan Shuling, the Director of the UP Institute of Civil Engineering. This year, we are celebrating our 110 years of civil engineering. So we have lined up a series of activities to commemorate our anniversary, our 110 years. So if just to show you our series of events, on June 3rd, we started with the launching of our photo contest. We'd like to invite, especially our alumni, to submit their photos and their memorable stories of their life in UP and in civil engineering. Yan, surprise po ang ano dyan, ang prize. But remember, it's the recognition that counts. Pero totoo po, may premyo din yan. On June 13, we launched our status report through a video that has been uploaded in our Facebook page. Kindly check it. Paki-like din po and share so that more people will be able to see it. Sa mga nanood na po at nag-like, maraming salamat. We also wanted to meet with our students last June 19th, but we had to postpone it to a latter date so that we will be able to incorporate the changes that we will have for the coming semester. And then for today, we have this book launch and the webinar by Dr. Tabios. So this is the first of this series of webinars. And then for the full month of July, we have different speakers every Friday at 3 p.m. And then it's going to be capped by a virtual recognition rights, which we plan to hold on July 25th. And for the details of the upcoming webinars, so we're starting with today. This is on water resources systems. And then on July 3rd, we have the future of the civil engineering profession by Engineer Ramon Aliado. And then on July 10th, will be about construction management during COVID-19 by Bo Gangayko, the Managing Director of Design Coordinates. And then another topic on construction is cement, entitled Cement, Concrete, Aggregates, and Rebar Supply Outlook by Dr. Francis Felizardo. So all of the topics, we chose topics that are relevant for the new normal, how we are going to be affected, and then how do we adapt to the new normal. On July 17th will be about transportation. So it's going to be, we have two speakers, transport operations under the new normal based on the DOTR plans. We have the Assistant Secretary for Planning and Project Development from DOTR, Dr. Maria Sheila Napalang. And also another speaker to talk about the future of transport planning for resilience by John Mark Lucas. And then the last of this series would be on July 24th. The topic will be adopting the Philippine Building Act of 2020 with S&T innovations in regulations and standards for a new normal, to be given by one of our professors also, Dr. Pacheco. So for this afternoon, we have the book launch and webinar. So this book, this event, we originally planned to hold in March in time for the Water Month, World Water Month, and we had the World Water Day on March 22nd. So tamang-tama sana. This was our contribution to the celebration of World Water Month. But unfortunately, the lockdown happened because of the the pandemic. So fortunately, we were able to adapt, and today we're still able to publicly present, no, the the book by Dr. Tabios, and also the lecture that he will give. Okay, so the program flow for this afternoon, it's first we'll have the the launch. Dr. Tabios will talk about the book itself, and then he'll proceed with a lecture regarding water systems modeling, and we'll have an open forum there, and then of course the closing remarks after all of this. So we invite all of you for we invite you for your comments. You may uh, write them down here on the dashboard. There's a Q&A there. Uh, even while the speaker, even while Dr. Tabios is speaking, you may uh, type in your comments. By the way, we'd like to thank all of those who pre-registered and you had your initial questions already there. So before I give the floor to our moderator, I'd like to acknowledge special participants. Sorry, I don't have a real time list of all our attendees, but let me acknowledge the support of the UPERDFI. We have a new president, Mr. Ferds de la Cruz, and the Vice President Dante Broyones. Hi. And Ma'am Edith Atienza. And we also saw in the registration Mr. Tito Aliga, Lilith Tumbocon, Sir Badong, Dr. Salvador F. Reyes, one of our former Institute of Civil Engineering. So we are very grateful for your presence here. Special thanks to PICE for supporting our event and for broadcasting our event to the PICE audience. So I'd like to greet all of you and again express my gratitude. Okay, so now I'd like to give the floor to the moderator for this afternoon, Dr. Roy Soriano. Dr. Soriano is the group head of the Water Resources and Coastal Engineering Group of the UP Institute of Civil Engineering. So you may take the floor now. Dr. Soriano, of course, would properly introduce our esteemed guest, Dr. Tabios. And in advance, Dr. Tabios, because I have to leave in an hour, maybe I don't have the chance. I'd like to congratulate you for the book. And thank you so much for being with us this afternoon. So again, good afternoon to all of you. And I'd like to give the floor now to Dr. Soriano. Thank you.
Thank you, Director Tunet Tanchuling, and good afternoon, everyone. For those on Zoom and Facebook Live, welcome to our book launch and webinar. My name is Roy Soriano, and I have the pleasure of moderating the webinar. This afternoon, we'll be hearing from a colleague and author of the book, Water Resources Systems of the Philippines, Modeling Studies, Dr. Guillermo Tabios III, or just Glenn for those who feel close to him. But first of all, I would like to congratulate Glenn for publishing a very important reference material for anyone interested in water resources systems in the country, especially now that we are feeling the heat again and people are asking, do we have enough water? But before we ask him to present the book and speak to us, let me give a brief introduction about the author of the book and our speaker for today. Dr. Guillermo Q. Tabios III is a professor at the Institute of Civil Engineering and Research Fellow of the National Hydraulic Research Center, or NHRC, at the University of the Philippines, Diliman. He teaches and conducts research in stochastic and computational hydrology, hydraulics, and water resources engineering. He obtained his PhD in civil engineering from Colorado State University, Fort Collins in USA, 1984, and his BS and MS in agricultural engineering, major in land and water resources engineering from the University of the Philippines at Los Baños in 1977 and 1979, respectively. Prior to joining UP Diliman, he was a research associate in the Hydrology and Water Resources program at Colorado State University in 1985 to 1987, and was a research faculty of the Hydraulic and Coastal Engineering Group at the Department Civil Engineering, University of California, Berkeley, from 1987 to 1996. He is an academician of the National Academy of Science and Technology of the Philippines and a member of the American Geophysical Union and International Association of Hydro-Environment Engineering and Research. He was chairman of the Institute of Civil Engineering from 2004 to 2007, the director of the National Hydraulic Research Center from 2008 to 2015, and at the same time, member of the board of directors of the Philippine National Water Resources Board. He was the chairperson from 2015 to 2017 of the Regional Steering Committee of the UNESCO International Hydrology Program of the Asia Pacific region. That's a lot to take, right? So, but then of course, before we ask Glenn to present, there are already initial questions. Let me ask Glenn first. Glenn, are you there?
Yes, Roy, thanks.
Glenn? Oh, hi. Okay. I thought you were missing. Okay. Hi, Glenn. There were like a few questions that were already posed to you very early on. What made you come up with the book? What was the inspiration or motivation behind it? I think these are general questions that are always being asked from someone who writes a book. And what are the target audiences or potential buyers and the challenges you encountered in coming up with the book? Yes, Glenn?
Yeah, I guess for academics like us, teaching at the university, and then so we love to talk. So we keep on, give seminars, conferences, we present papers. But on that hand, we also do researches, doing some extension work to government agencies or even do some consulting work. So all those years, I think not only like you want to talk about what you teach or what you do research on, but you like to write it down. So hopefully, even beyond those times that you will not be able to talk to them or be live always to talk to them, it's always nice to write a book. I think as an academic, while writing papers is, you feel good about it, but writing a book, which is sort of a compendium of what you've done in so many years, and which is what happened to me. I've done so many work here and there with National Hydraulic Research Center, as well as some of my consulting outside, So that's basically the motivation in putting everything together and then to be able to share in a very structured as well as comprehensive manner what you've done.
Okay, that's great. So thank you, Glenn, for sharing those insights to us. But I believe people wanted to know more about the book, and you have a presentation. So please do tell us more about the book, Glenn.
Yeah, I think some of the questions may be answered with my presentation. So if I may share, I think my screen. How do I do that? I already pop up should the moderator, we are here. Okay.
Screen.
So I put share, right? There you go. So and then slideshow. There you go. So the book is like that. In fact, you can see in the background, I have copies of the book. So I've been always wanting to, of course, one of the big things about writing a book is that you always wanted to show your affiliation. So I'm very proud, of course, to be with the Institute of Civil Engineering at the University of Diliman, as well as being a fellow of National Hydraulic Research Center, in which Dr. Roy is the chair. And then I'd like to thank Dr. Tunet, the director of our institute. I think she's still around, but it's always nice, even in the Zoom, to be able to make presentations like this, especially introducing what's the book all about. So let me get to the next page. So I think in any book, it's always not complete without a dedication, and especially a dedication to your wife. Otherwise, you'll be, you know what I'm talking about. So that's the dedication page. So the book is basically talking about modeling of water resource systems in the Philippines. So as I say here in the slide, modeling of water resource systems is essential to develop science-based information, policies, and management actions for effective water resources planning, design, and operations. So the book is basically written to present all those different modeling experiences I have, as well as modeling studies of water resource systems of the Philippines. And of course, my advocacy being a modeler is to use modeling tools to ensure that we have science-based policy formulations and management decisions in the planning, design, and management of water resource systems. So the book really contains a suite of all these different water resource modeling studies, from surface, groundwater to groundwater modeling, reservoir planning and operation studies with optimization, simulation models, reservoir sedimentation studies, hydrodynamic and water quality modeling for bays and lakes. It has also flood and dam break modeling studies, pipe network distribution modeling with optimization, and then two kind of offshoot nowadays. If you do modeling, you wanted to incorporate climate change studies as well as modeling application for environmental assessment studies. So let me get into the intended audience, and I think Dr. Roy asked me. So basically the book can be used by professionals as well as practitioners, because I've included quite a bit of some articulation of the experience in, problems encountered when you do modeling, and as far as calibration, etc., as well as undergraduate and graduate students, because the book, I think, contains quite details as far as model structures and solution algorithms. And of course, the book can be, in general, used in the Philippines or even some other countries. So I think the Philippines is quite unique as far as settings and conditions, being a humid tropical hydrology setting, as well as it's the archipelagic watersheds. So you have short, steep from mountain to coast river system. So that's quite challenging when you do water resource modeling from the hydraulics of flow, hydrology of flows. So the book in this case offers, I think, different perspectives and experiences in modeling these types of water systems. in comparison to other systems in the world. So let me get into the contents of the book. It's got 12 chapters. So what I'll do is go through all these 12 chapters, including the appendices, in one slide per chapter. So the introduction, I've given here the outline, which if you look at the book, you can actually look at the Springer website, and then there is what you call the front matter of the book, as well as the back matter. You can download that. That's available for free. So it's got preface as well as the acknowledgement, the table contents, and some of the preliminaries about the book. But anyway, chapter 1 just talks about the purpose, science, and the art of water resource modeling, and then some section on some general discussion the status of modeling water resource systems in the Philippines, and then the organization of the book. But I'm showing you some figures here, which is in the book. But anyway, I'll expound on this when I get into the webinar later on. This slide in particular, where I'm talking about these cartoons of the studied environments and the target environments. So chapter 2, which is like not quite about modeling of water resource systems, but status as well as the state of water resources in the Philippines, the physical water resource systems, as well as some section on water governance, which is it's always important nowadays that when you talk about modeling, and in fact later on my webinar is to link science and technology to policy formulation and management decisions. That's essentially dealing with water governance. So first of all, there's like you have background as the usual thing when you talk about a Philippine setting. I mean, a country in particular, you want to talk about the climate, physiography, water source systems, etc., the status of the water demands, irrigation, flooding issues, environmental problems, etc. And then finally, as I mentioned, the status of water governance. So that's the. So there are several papers I've been involved, or work I've been involved in water governance, but part of this is shown in this chapter. And then some preliminaries on modeling, which I titled it Science and Art of Water Resource Modeling. So that first section is linking science, policy, and management. So I'm going to expound on that when we get into the webinar. So I leave it at that for now. But a big part of the talk later on is on chapter 3, actually. And then, of course, the examples will be on the next chapters, which is the different model applications. So chapter 4, I begin with surface and groundwater modeling for water utilization. So I have some preliminaries on how you do modeling as far as these large basins are concerned. But you have, for instance, applications here. It says Pampanga River Basin, and then the Agno, but it's a little bit not shown properly there. But anyway, these two river systems, Pampanga is quite a big one, about 10,000 square kilometers drainage basin. So quite an interesting basin to model as well as to do water resource studies. And then the Agno is even bigger if you look at the Agno, which includes your Tarlac River and then the Kamiling River, etc. So that's even bigger than the Pampanga River Basin if you include those other basins like the Buid River and so on. I'm going to show you that a little bit in the applications. So this particular chapter shows you water utilization studies. So you have a surface water, groundwater model, and then given the water demands in the area, how then you can allocate these different water sources, surface or groundwater, to satisfy demands at specific cities or towns in Pampanga River Basin. So this was a study I've done with Manila Water Company. So that's more than 10 years ago. So these are like applications of models for these kinds of studies. Chapter 5 gets into reservoir planning and operation studies. And when you have already a reservoir where it involves making decisions, that's where you have to come in, or you have to include optimization. So the simulation models do the hydraulics and the hydrology of flows, and then the optimization makes decisions as far as how would you release water deliveries for irrigation or hydropower from your reservoir. So again, you have examples here, ANGAT allocation, which is on a monthly basis, but I also have applications later on a daily basis. And then again, the upper AGNO, which is all these reservoirs in the upper AGNO in particular. And then the proposed Agos reservoir system, which includes actually Kaliwa Dam, Kanan Dam, Agos Dam, etc. And then you have, this 5.4, section 5.4 in particular, I'll expound on that because I'm going to show you even the ANGAT in the webinar application in that particular river system, where I'll expound more on how the reservoir planning operation studies were conducted. And then I have this reservoir sedimentation studies. Of course, if you're talking about a watershed and then gets into your reservoir sedimentation, then you also need to include the river sedimentation process. So this one, applications include the Balog-Balog Reservoir, proposed Balog-Balog Reservoir system. You have the San Roque Reservoir, which was built, the last major reservoir, the latest reservoir built in 2002, a large-scale reservoir that's in the upper Agno River Basin. And then the Pulangi Reservoir, which is the interesting part about the Pulangi Reservoir is that it was built with a sluice gate. This one here. A sluiceway, which is a bottom sluiceway to flush out sediment. So it's an interesting study. And then in fact, now in the next 2 years, I'm involved actually in a World Bank study to do additional sediment flushing studies in this reservoir. Chapter 7 is quite large-scale modeling of a system. This almost, you're talking about hydrodynamic and water quality modeling for bays and lakes, but this one in particular applies it to Manila Bay, which includes your Laguna Lake system, or Laguna Lake. So if you look at the watershed surrounding the lake, the entire Manila Bay and the Laguna Lake system, it's almost 20,000 square kilometers. So you cannot ignore, in other words, the watershed that flows into the lake, into the bay, Manila Bay, and into the lake. So if you're talking about managing the environmental health of, say, Manila Bay, then you have to look at all these different water quantity, quality process surrounding the bay. And Chapter 8 talks about flood and dam break modeling studies in this in the book. there's one application to the Pasak Delta. Pasak Delta is quite interesting because it's got this network of one-dimensional channels. So it's handled using the unsteady network flow model in the Hydraulic Engineering Center River Analysis System, HECRAS. But what's important here is that it looks at the Pasak Delta flooding as far as the influence of a moving storm. So that's the idea of doing this study. Now, another application, of course, you have the Marikina River flooding during Typhoon Ketsana or Typhoon Ondoy. So that has been of interest for several people. And then another application is to look at the alternative flood management plans for Cagayan River. And then you have dam break. Finally, this was applied for a dam break that happened in Cavite, I think, September 2006 during Typhoon Milenio. But other application in the book is on a dam removal, intentional dam removal problem, where there are some dams when you decommission a dam, you break the dam and then let the water flow. So you might be interested in that. But this particular dam break model that I'm using, which I developed, it is looking at dam break problem with sediment transport. So not only that you break the dam and then look at the water flow, but also how the channel or the reservoir and then the channel changes, morphology changes because of this rapid massive movement of sediments or massive movement of sediment or bed erosion. So that's the interesting part of that. Number 9 is a pipe distribution modeling. There is this model, EPANET, which does a hydraulic model of a pipe network distribution. So it's a pure simulation model, but you can embed this in an optimization model and you can really enhance or expand the application of the EPANET for planning studies, even abnormal operations, and even detection and surveillance of what you call non-revenue water. So if there is a pilferage, you can even use that to detect or to do a surveillance. I'm going to talk about this also in my webinar later on, so I'll expound on this later on. Now, chapter 10, we have these reliability studies of reservoir under climate change. So the bottom line here is that what do you want, what can you expect in your reservoir system, in this particular Angat and then Upper Agno reservoirs, if you have climate change? So I'm looking at the 2050 climate change scenario. So for instance, in the Angat, I have the downscale stream flow to the Angat River Basin in the 2050 was based on a study by Professor Koike of the University of Tokyo. So he looked at different global climate models, see which one is appropriate to the Angat in particular, because you have almost 25 or so of these GCMs all over the world. But anyway, you narrow it down to 5, and then we pick up 1 or 2 to represent the Angat hydrology. And this is on a daily basis, by the way. I'm just showing you on the left-hand side of the slide how do the different global climate models compare, and so on. The Upper Agno application is also the same thing. You have to have this global climate model projections in 2050, downscale it to the Agno River Basin, and then use that to do your reservoir operation studies. In other words, as if you're running, operating the reservoir with a 2050 hydrology. So that's the idea, and then see what's the impact of the climate change scenarios during that period. But on top of that, I also incorporated here, in the case of Angat, future reservoir sedimentation. So if reservoir has accumulated so much in 2050, what happens? So chapter 11 talks about environmental assessment studies. So I have two particular applications. And Subic Bay hydrodynamic water quality modeling, very much similar to the Manila Bay, Laguna Lake hydrodynamic water quality models. But this one in particular, I got involved in the study in 2004 as part of an integrated coastal management plan. So I'm going to expound on this again later on in my webinar, so I'll leave it at that for now. But another interesting application of models is the looking at the risk of polluting the Novaliches Reservoir here, which is the La Mesa Dam, actually. So the La Mesa Dam, the reservoir associated is called Novaliches Reservoir. And then there's a dump site, which is an open dump site, the Payatas dump site, which already closed. But there were concerns before that maybe some of this groundwater pollution, pollutant leachate will get into the reservoir. So this study was conducted for that purpose. So I think we found out that the risk of polluting the reservoir from the Payatas dump site leachate is very, very small. But then maybe another concern will be the air pollutants coming from the dump site and then getting into the reservoir. But that study, I haven't seen one yet, but maybe that can be another study. And then finally, you have this closing chapter, the imperatives of water resource modeling and application. So I talk about some key considerations in modeling water systems, the need for monitoring and data that you need to collect, data to feed into your model. But if you don't have so much data, the model can complement or fill in the gaps in your data. But in any case, you need always data to gain more insight into your system on top of your modeling efforts. And then I get into science-based management decision tools. Again, that's talking about capacity building in particular, where, of course, not only to apply models, but to be able to build capacity not only to modelers, but if you wanted to translate, to communicate, or even to, later I'm going to talk a little bit about linking science and technology to policy and decision making. I'm going to talk a little bit more about that, why the capacity building comes in. And then, of course, I end up with sustainability science transdisciplinary approach, which is needed when you talk now about modeling and studying large-scale, complex, uncertain systems, and particular water resource systems in particular has those kinds of uncertainty, complexity, etc. And finally, on building urban resilience to water-related disasters. So the book ends up with appendices on those different models, in particular Sacramento, Swatch, which are watershed models on optimization, and then on the two-dimensional hydraulic modeling. So this contains quite some detail of the methodology that, it's a good reference, I would say, as far as if you want to implement this model and really understand how these models work. Because nowadays, a lot of these models are in the engines of this big HEC HMS or hydrologic modeling system, and then HECRAS. But you don't see so much anymore how the model works unless you read the manuals. But how specifically they work, maybe some of this is contained in the appendices. So that ends the book. So I'm gonna turn it down. It comes to the music, but Wait a minute. How come I'll stop? Okay.
Okay.
So,
Thank you. That's good. All
so
right.
the title of the book, I think you've seen it. Sorry, I didn't even.
Okay. Thank you, Glenn. Thank you, Glenn, for giving us a preview of what to expect from your book. And now I
Okay.
think some questions are coming in already.
So, did you want to go ahead with the webinar, or you want to
Yeah,
have
just
some?
one more, just one question that you may answer
Okay.
quickly. I think
Okay.
because some people are asking right now. I think it has something to do with the book. Is where is the book available, and how can they get copies of this book? One related question is it available in CD, or can it just be download the file itself?
Yeah, the book. If I can share actually this last part. Are you able? Can I share this one?
Yeah, go ahead.
So if you look at there are several online book stores. You have Amazon, and then you have Barnes and Noble. They sell this book, and in fact, it's available from the Springer publisher themselves. It's available as an ebook as well as a physical book. But if you order a physical book, it may, I don't know how long it takes nowadays with this COVID pandemic, but otherwise you can buy the ebook. So if you buy, I think you just you download the whole book.
Okay. That's thank you for that clarification. And of course, many are asking already, Glenn, can they get discounts, especially those working with the government or state universities? That's,
The publisher, you cannot really get unless you like libraries may have some discount, but as an author in particular, I can get a discount, 40%, discount, but still going to be expensive even for me. Although I bought extra, but it hasn't
Okay.
arrived yet because of this.
Okay, thank you for that. So let's to learn more from the book. I think at least we know where to get the book now, and we want to hear more from you. And let's proceed with the webinar itself. So, Glenn.
Yes. So do you have am I still on share?
Yes, you are.
So I'm going to open up this slide. How come I couldn't? I thought I already opened this one. Okay, there you go. Sorry. So so we're on, Roy?
Yeah, you're on.
Oh, okay.
Go ahead.
So this particular webinar, so I think it's 3:46, so I'll try to finish it by 4. Are you able to hear me? So am I on? Can you hear? Okay. So this is the the title of my talk. So, linking science, policy, and management decisions through modeling of water resources systems, and in particular, Philippine setting. So, a lot of these materials were taken from the book, and all these years I've compiled so many of these experiences. So, that's the book, and then these I'd like to illustrate or give examples on how you could link science, policy, and management decisions. So just the preliminaries here. So you've seen this slide in the book where when I talk about linking science or science, it's research-based as well as experience-based knowledge. So I guess you can call experience-based also as indigenous knowledge. So we want to link science to public policy and management decisions. So if you look at the chart, which I adopted from Georgia Kakos, I think it's from Georgia Tech in Georgia, US. So you have these scientific disciplines. So nowadays, when you do water resources, it's really encompassing several disciplines: climatology, meteorology, remote sensing, hydrology, ecology, etc. So even later on, I'm going to mention about transdisciplinary approach. If you're a hydrologist, if you do some sociology, you're a social hydrologist. If you're a hydrologist, you do some ecology, you become eco-hydrologist. Similarly, if you're a sociologist and you want to do some hydrology, you can be called a hydrosociology or eco-sociologist, and so on. So that's basically how you transcend from being multi or monodisciplinary to transdisciplinary. But anyway, going back to this slide, then you have these public policy actors, civil society, stakeholders, government agencies, and so on. And then all these policy, you can translate them into what you call shared vision strategies, which ends up actual operations, reservoirs, allocation of water from ANGAT to domestic water supply as well as to irrigation and so on. So those are the management decisions. But central to the linking is this decision support systems, which essentially evolves around models, analysis, analytical tools, methodologies, etc. And of course, part of that is your data, information systems, how you're able to present results, how you're going to display how the water hydrologic process move water here and there. So, and decision support systems are developed by research institutions, government agencies also be involved, scientists, consultants, etc., professionals, and so on. So these are supposedly the scientific disciplines are linked to public policy and management decisions through your decision support system. So there's also a feedback loop here, where if there's a need for institutional improvement from management, you go back to the public policy actors, and then if you need technological advancement, you go back to your DSS, and then back to your scientific advancement. So you always want to have like this iterative loop from top to down, down to up, and so on. So I'd like to focus a little bit on that box on decision support system. So it serves as a vehicle or to link, science and technology. And in fact, I look at it as a platform. So not only that you have these models and so on, but later I'm going to show you the DSS. It should serve as a platform to bring together those different disciplines, people, institutions, and of course the stakeholders in general. And why you want to bring them together? Because you want to improve understanding on how the water system functions, how you can evaluate feasible alternative management options, including evaluating the impacts or consequences of your actions. And of course, I mentioned already about building a shared vision to develop consensus for development, sustainable development and utilization of the water resource system or the water resources in general. So this particular slide, I took it from Lux and Van Beek. This is a nice book. Actually, you can download it. It's an e-book. So it's a nice water resources planning and management book. And it contains this particular slide where I mentioned about the model system here, composed of the hydrologic, hydraulic, natural system models. But really a big part of this to serve as a platform or to serve as a vehicle to link the stakeholders, for them to develop consensus and so on. You need this user interface, a graphical user interface, a GUI, you call it, that's also user-friendly. So then, not only I present tables and so on, but really showing graphically what's happening in the watershed. I think people will have a better way to appreciate what happens in the system. If you do this, do that, and then you're able to really link properly science technology to policy actors and the managers. So that's how I look at the DSS, more than just a platform like a model, computer model, but really to be able to talk about it. So the model system in the DSS are composed of your process-based models, hydrology, hydraulics, etc., water quality models, and then you have optimization simulation models. You can even have statistical stochastic models and decision analysis models. So again, the purposes of this to understand the behavior of water resource system, to evaluate those strategies to restore, enhance, or maintain, the integrity of your water resource, even for water regulation. It can be used as a detection and surveillance model, and then for forecasting, in particular for real-time operations or even long-term forecasting, looking at what happens 50 years from now and so on. So before I get into those examples, I'll just mention a few of these imperatives to modeling water resource system. And again, these in chapter 12 of the book, it contains some of this. So I mentioned about looking at a water system as a comprehensive system. So it's not really like a open system is bounded by a watershed only, but if you look at the hierarchy of soil, water, and air environments, and its interaction to the flora, their interaction with flora, fauna, and human beings or human settlements, including the built environment, you have this water, which the medium of water is the soil. Your sort of the river bed. And then the air, of course, on the earth system, you have water and then soil as perhaps the medium or maybe even air could affect of course, definitely water and soil process. And this is what I call the studied environment. And then you have the target environments. You want to make sure that you have the water environment in which the medium is the soil, or maybe including the air. It's able to support aquatic life, flora, fauna, or terrestrial, and most importantly is human settlements. And perhaps in the human settlements, the built environment, how we modify, engineer our water resource systems, that's how it comes in. So in the case of modeling system, water resource system, perhaps we translate that in a much more smaller way, unless you have a global hydrology water resource model. But on a basin scale, maybe what you really need only is to be able to incorporate or capture the interactions of the hydrologic, geomorphologic, and ecologic process. So this is basically what I'm showing here, that I essentially talk about in hydraulics. When I teach, I always say that you always have to consider sediment transport, because the flow talks to the river or the riverbed, and the riverbed interacts or talks back to the water flow. So that's essentially talking about the hydrologic, geomorphologic interactions. On a large scale is even more. If you're talking about river change, landscape changes because of earthquake, etc., etc. So that's even a bigger scale as far as capturing or incorporating those hydrologic, geomorphologic, and ecologic interactions. Now, in the case of the Philippines in particular, being a unitropic archipelagic country, it's typified by this landmass drained by river system with lakes and tributaries connected to your aquifers, but they quickly join the deltas or the estuaries coastline and near shore sea and open ocean. For instance, I'm showing here, this Manila Bay and then the Pampanga River Basin that contributes to Manila Bay, Bataan, Pasagwagwa, Angat, etc., Cavite. But if you look at a typical archipelagic country, you will find that these river systems, even in the Pampanga River Basin, until it hits the maybe Pampanga Delta, you have very steep slopes. Look at them. This shows you, this is the same scale as that. These are the 1:25. Those are fairly steep slopes. These 1:100. You can find this somewhere here. And the Mississippi River, for instance, the average slope is 1:100. So there are areas that's even lower. The Sacramento River of California, which runs about 500 miles, the slope, the average is 1:5,000. It's like 1 foot is to 1 mile. You can imagine that's 1 meter, maybe several thousand kilometers. 1,000 kilometers. So it's, yeah. So we have quite steep slopes. So this is quite a challenge in modeling, not only from a hydrologic, because of the steep slopes, maybe you have to employ hydraulic equations or hydraulic formulations to your hydrologic models. And again, being, you have these very steep slopes. So when you're talking about water resource management, you really have to combine integrated water resources and integrated coastal management. And this is what you call S2S, the continuum, or the model domain in particular. The coverage of your model should be from source to sea. So that's a new thing now, where you combine IWRM with ICM as far as managing water resources in the Philippines. And in fact, you can even stretch it. Now there is a group by Roger Falconer, I think is with in England. They even call now the C2C, cloud to coast, integrated water management solutions by C2C. So this one in particular is modeling. I think they have this environmental hydraulics modeling group. So they talk about modeling from your clouds, cloud physics, to your catchment all the way down to the ocean. So now I'll get into it's 4:01, so I think we should be in good time here. So I'm gonna show you experiences in modeling water resource systems of the Philippines. So I'll begin with modeling to augment Metro Manila's water supply. So I've updated this a little bit. So hopefully the numbers are more current. We have different water sources for Metro Manila's water supply. You have the Bulacan, of course you have the Angat that comes with it, gets into the Ipo and so on. The Umiray is a transbasin. There's a transbasin water transfer tunnel that moves water to Angat and then goes to Metro Manila. And then, of course, you have groundwater available. Laguna Lake is being tapped for, and then I'm going to talk about this new Centennial project, which started during the administration of President Aquino, the Kaliwa Dam, but the Agos River system in particular. So the current status as far as water sources for Metro Manila, you have the Angat system with including La Mesa and Umiray. The estimate is, I think, 4,200 MLD. From Angat alone is about 4,000 MLD, but including local inflows from Novaliches Reservoir or La Mesa Dam, as well as Ipo, maybe you have additional 200 MLD. That's the all year round inflow. And then you have Laguna Lake from Maynilad 300, I think. Maybe you have the Manila water, additional 150, it can be even more. And groundwater, about 800 MLD. It used to be, I put here 750, but now maybe they have reactivated some of the groundwater pumps, so maybe 800. But anyway, if you look at the water demand, which is from the MWSS, I think 2010, I mean, this study was done about 2010 or earlier. The 2020 water demand is about 6,000 MLD. Now, so we really have a deficit. If you have wet year, you're okay. But if you have a dry year, you'll really experience a water deficit in Metro Manila. So this study was done sometime 2012, where we look at the new Centennial Water Supply Project for Metro Manila. And actually this particular system, the Kaliwa River system, has been already conceived as a water source, potential water source for Metro Manila, way back in 1972 during Marcos' administration. But some change in administration, the Laiban Dam, which is on Kaliwa River, it was stopped, the Laiban Dam project. And although 20% of civil works were already completed and attempts to revive during the time of President Ramos, Estrada, Macapagal, and then even President Aquino, but again, there were some funding or resettlement issues and so on. So I think now with President Duterte, they are really seriously looking at this, the use of this Kaliwa River, and maybe look beyond that, which is the entire Agos River system. So I call this the Kaliwa Kanan Agos River Basin, which is about 951 square kilometers. Remember, the Angat River Basin is about 580, I think, square kilometers. So this one is even bigger. But the nice thing about the Kaliwa Kanan Agos River Basin, it's on the eastern side of the Sierra Madre, where you have a type 2 climate. No dry season, rainfall evenly distributed just like your type 4 climate. Although it's much more pronounced wet or rainy period during December to February. So this in contrast to your Angat Reservoir, which is on the western slope of the Sierra Madre, where you have type 1 climate, pronounced wet and dry season. So perhaps I think with the Pacific maritime climate coming in here, orographic effects of the Sierra Madre, then you have this much more rain on this side. So if you look at the Kaliwa Kanan, there have been studies way back, I think as early as 1972 by Electrowad, already looking at this. That's why the Laiban Dam was already conceived during that time. So this particular study is really project sequencing and staging with optimization simulation models to augment your water resource for Metro Manila, the water source for Metro Manila, to meet the increasing demand. So why you wanted to stage or sequence the different components of this Kaliwa Kanan Agos River system infrastructure, because you don't want to build right away everything now to satisfy your demand 30, 40 years from now, which is going to be so expensive. As far as even your investments, it's not optimal if you spend all the money right now. So this is like optimal investments on timing, optimal timing of investments. So how you do that, you look at the different possible configurations with different components, different reservoir here and there and so on, and you run the hydrology, do reliability analysis, and then see, based on that, how you can then sequence the project. And all of this, because you have reservoir, requires optimization. So that's what happened in this study. So we have 9 alternative water resources system configurations or components. And the bottom line, we do then watershed hydrology, and then you do optimization with this objective function, which is you want to minimize water supply demand violations. You want to maximize hydropower if you have hydropower. You also don't want to spill so much for flood control purposes. This is just an example of watershed generated flows. By the way, in the case of Kaliwa Kanan, we delineated the river basin into 182 sub-basins. So if you look at one reservoir, maybe there will be 2 or 3 or 4 sub-basins that inflows into those. So that's the importance why you delineate it into so many small units. So this is the hydrology of the, just for these 2 sites, but you can get it from those, for those 182 sub-basins. And then you can do your optimization. Like, for example, this particular slide shows you that if you are going to make a release, which is very conservative, in the long run, you'll get this much, 85% reliability, 864 MLD. That means almost 310 days a year, you get 864. But if you release quite aggressively, 20 CMS, in the long run, your 85% reliability is only 585. So when you do optimization, or part of the optimization process, that if you try to release only the target release 15, you'll get higher. So perhaps from a day-to-day operations, you only try to release 15, not more than that, not less than that. And then in the long run, you'll get 924. So that's the reliability. If you have 53-meter high dam, it's a bit lower if you have a 43-meter high dam. So that's the idea behind that. But anyway, after doing all this optimization simulation, then you can sequence your Kaliwa Kanan project, Kaliwa Kanan Agos River, by building maybe, but this was done in 2012, so it's late now, we're now 2020. But anyway, this basically shows you that if you have Kaliwa low, then later on you build Laiban Dam, you have Kanan diversion to Laiban, and then you have Kanan Dam, then you go to Agos, and so on. Then you are trying to catch up the blue line, which is the water demand for Metro Manila. So definitely, with the Kaliwa Kanan Agos River system, you're still not, you'll not be able to capture or satisfy the demand, because this is the Angat here. So you really need other sources. So that's the study. Better move on quite quick here. This is for the case of the Angat Reservoir, as far as with climate change and then with reservoir sedimentation. A side discussion here is the issue of competing water use for domestic supply, irrigation from Angat, and in particular, and also with hydropower. You'll notice here that the releases to NIA for irrigation, goes through a 200 megawatt hydropower plant, which is owned by K Water SMC. The releases to Metro Manila has an associated hydro power of 46 total 46 megawatts. So if I were the hydropower people, I would rather want to make releases to irrigation more than to domestic water supply. But that's the competing water use as far as, of course, irrigation people would also, the farmers would also want irrigation water releases. But then, if you look at the water code, you may have a priority, or you have a priority to domestic water supply, especially when you have a water crisis. So then you'll have an issue with competing water use. Anyway, this one in particular, again, you do combined optimization, but instead you have the Angat, Umiray, Ipo, Bustos watersheds here to be able to do all this. And then you employ this optimization, how you make releases to irrigation, to domestic water supply. And you can come up with results like this. On a monthly basis, the daily reliability as far as the ability to release water for MWSS, that's a release to Ipo Dam, or to irrigation, which is a release to Bustos Dam. If you are, with the current conditions now, if you look at the overall, during the months of February, March, April, and so on, you'll see like 60 as opposed to 80. This means if you have a reliability of 80%, less than the ideal water demand of 46. This means 80% is like 2 out of 10 years. You'll experience that you won't get the 46. That's the idea behind it. So if you see some yellow columns here or rows, then you'll have a deficit. If you have climate change, you'll have also deficits here for the Angat releases to domestic water supply, also, but even more so to Bustos. But with future reservoir sedimentation and then, you'll have more. In fact, the next slide just shows you if the future reservoir sedimentation, you'll have a smaller reservoir capacity now. So the elevation against the volume, the 600 as of now, now it's about 720. So in 2050, after 30 years, maybe you'll reduce by about 120 million cubic meters. So this is the effect. If you have reservoir sedimentation all over the place. So I think the reservoir sedimentation for that matter will be a much more bigger problem compared to climate change for that matter. There's another application, which is the book, which is I'm particularly also interested in the application of this model actually to real systems. So typical water distribution system, you have maybe a water supply, reservoir, you have booster pumps, you have the grid of these users, you can have like control valves. Of course, you have measurement points or gauging points, GPs, but on top of your nodes that in your pipe network system that you derive water for water deliveries to households, you might have some pilferage, non-revenue water, or even leakage if you're not able to. So the idea behind this exercise is to employ, your IPANET model, but embedded into an optimization model so you can enhance or expand its capability. So essentially, if you already have the optimization attached to it, then of course you have a much more enhanced type network model. So I think I won't go through the details of this in the interest of time. Your objective functions, you can have a choice of them. Decision variables as far as base demand parameters, you have roughness coefficients, pipe diameter, and so on. You can open, close pipes, etc. But the bottom line here is that you can then use your Ethernet with optimization to calibrate your model automatically. And then you can also use it as a planning model. The details are here. The decision variables could be this one. The objective function may be this. Constraints and this, the output that you'll get. And then for detection and surveillance, you can locate where are those pilferage, where the pilferage could be happening and so on. And finally, normal operations. And then this is just an application of the enhanced Ethernet with optimization for model calibration. Imagine that in this particular example, there are 318 pipes, roughness coefficient to be optimized, to look for the optimal or the proper roughness coefficient. And then base demands to be optimized 99 times 24 hours. So a total of 2,800 decision variables. So if you do that manually, it's going to take you maybe a good 5 years to do it by trial and error. But if you do optimization, maybe a good 15 hours or 10 hours. So this is the improvement without optimization in model calibration. These the observed, the black curves, and then the blue lines are blue curves are the without optimization. But if you do optimization, then you are very close. You can quickly go close to the observed gauge flows or observed pressure flows, because what happens is that when you calibrate, you want to capture or mimic the observed data. Finally, well, not finally, but I have two more applications. These for San Roque. Maybe I'll not go through this quick. I'll just go through this quickly because in the interest of time. Again, if you look at the sedimentation is quite a concern. The Ambuk law, for example, from here, 300 MCM, now it's only about 100. The Binga, it's somewhere here 70, but now it's only about 25. So we want to make sure that San Roque, if there are sediment management schemes, then we might as well really do it now. So this is the Ambukla, Binga, and then San Roque at the bottom. So that's the San Roque watershed. You have to generate, since we're interested what happens in the next 70 years, since we have only about 10, 20 years of data, we generate rainfall, which looks like this. So this is the historical, which is 10 years. We generate for 70 years using this Poisson rectangular pulse stochastic model, run through or put it in our watershed model, which is sediment yield, run it through the river for sediment transport, flow and sediment transport in the reservoir. Then we can come up with simulations, like you get this reservoir life, and then what's the impact on energy generation or water yield. Finally, Subic Bay application, again, this quite a large scale model. If you look at the major factors affecting the Subic Bay process, you have the watersheds, soil and erosion from water pollution from the urban areas, density effects of salinity variations, and then you have tidal forcing, wind forcing, etc. So to be able to capture all those different processes, you need to sort of combine these different models. In this particular case, we have the watershed model, the Princeton three-dimensional ocean model. We have advection, dispersion for the water quality, and you can run through the watershed. This is a Subic Bay. And if, for example, if you have different loadings from these different points, you can run like BOD, biological oxygen demand concentration simulations for several days in the Olongapo, so much BOD, this Hanjin area. Depending on the interventions that you make, you might have future scenario 1, 2, and 3, and then you can also see what happens after 90 days and so on. This was one application, is an oil spill simulation, which was an incident in August 2006 where there was deliberate dumping of bunker oil from a boat. So this basically shows you that it dumped here. After a day, it becomes like that. It's a little bit south of this Grande Island. But after 5 days, it reached this area here, White Rock Resort in particular. So they observed after 5 days. So basically, this confirms, or you could have used this as a foresight if there is an oil spill, what will happen, how you can predict when it will arrive in your area. So final remarks, I think I've mentioned already about the importance of the decision support system, which is part of the IWRCM, Integrated Water Resource and Coastal Management Planning, to link science to policy and decisions. However, in the Philippines, I always like to emphasize is that modeling is not really quite popularly used or not quite common in practice, especially in the government agencies where they manage our water resources, maybe because of investments, lack of investments, and so on. But what I'd like to bring up here is that perhaps we should have a dedicated modeling group for water agencies that manages our country's water resources. So then, in that case, we can do like continuous updating our master plans. We can do adaptive master planning. We can do continuous operational studies, recognizing that water resource systems, they change quite a bit. They're so dynamic, uncertain. They evolve so much in time and space due to land use change, anthropogenic activities, climate change, even including socioeconomic and political changes. So finally, 424. This is the last slide. Anyone there? Hello? You're on mute, Roy.
Okay, now we are on.
Sorry.
A while. No,
I
I
hope,
didn't sleep. I'm still here. Okay. Yes. We have already a few questions even before you started, but I think just for those who are still wanted to ask their questions, you can actually type them in the Q&A chat. If you are using Zoom or if you are using Facebook, following Facebook, you can type your questions at the comment section, and our panelists will be able to forward them to us. So please ask your question. Before you ask your question, you state your name and affiliation, and we'll just try to answer all of them. Also, before the end of this webinar, you can have certificates of participation. Just make sure to answer the poll question that will be flashed right after the webinar. Okay, so thank you for that presentation, Glenn. Now, there are a few questions, and I think you have actually touched on them, many of them, as you were going through the presentation. But let me just, maybe for emphasis, there was this question by Dante Briones on what is the government or the country doing or not doing that our water supply becomes unsecured in the future? Classic questions. So many of the questions are in similar tone. Maybe you can.
Yeah. I think my answer to that, I've been involved in government agencies. One time, I got invited at NEDA when President Aquino came in. They have this water sector plan for water resources, which was, I think, over 5 years or so during the time of President Macapagal Arroyo, developed that one. So it's like a wish list. I mean, it's a water sector plan. But when I look at it, it's like a wish list of what to do and so on. And some of them, if you look at that carefully, maybe even the wishes 20 years ago, 30 years ago. So the bottom line there, when I was asked then by NEDA Director Padaranga, I said, what we need is really an agency that will champion this kind of in water resources development. So I propose that an apex body, a water resources authority or Department of Water, whatever you call it, to really orchestrate, conduct all this, push for development of water resource systems, to be able to bring them to the people in right time, right place, and so on. Because the problem with us that in our case, we don't have one agency, an apex body, that will do all of this. We have 30 or so water-related agencies doing this. So nobody's in charge. Everyone's a cook, but nobody's a champion. So how could you really manage the country's water resources? Like small countries, like even in Africa, I've been to a webinar last night. There are like small countries like Senegal, so they have like 200 reservoirs, large reservoirs. They don't have so much water, but they have impoundment because they know during the wet season, maybe 2 months, 3 months a year, that's when they can get water. The rest of the year, no water. Philippines is similar to that. So I think it's high time that there should be a champion agency, not just a champion person, but an agency, an institution that will continuously push for water resource development to be able to provide water for all people, something like that.
Wow. Okay, thank you. I think this is similar, but more specifically for Metro Manila, and they are from Misael Camposano. I would like to ask, what are your recommendations to solve the water crisis in Metro Manila? And I think on a similar trend, Patrick James Dizon was asking on Zoom that he's asking about the groundwater. Is it still, what is the status of the groundwater now? Can NWRB lift the moratorium for extracting groundwater? So I think these are all related as well to your.
Yeah, of course, Dr. Roy is one of the board of directors of NWRB. But based on what I've just seen, as far as I've done some groundwater studies in Metro Manila. Since the moratorium in 2004, I think some areas in Metro Manila recovered as far as groundwater heads or groundwater storage is concerned, because we start pumping, and maybe also because of the concessions, the privatization of the water distribution system, where I think a lot of people switch from groundwater pumping to buying water, which is from the concessionaires, which is sourced from surface water. So I think two of them. But as far as groundwater is concerned, I think we should be able to tap groundwater provided that it should be properly managed. What I mean by managed, there should not be like before. I think there was really some excessive withdrawal of groundwater pumping. Because excessive groundwater pumping, because NWRB, as you know, Dr. Roy, doesn't really have a policing capability to do a detection and surveillance as far as those, even right before, in front of our nose before in 2000, early 2000, there were still people pumping groundwater without permits within Metro Manila. As far as the water sources, I think I've done some talks about water sources. April 2019, during the water crisis I prioritized some of those. Groundwater is still a good source, but it should be properly capped or restricted. It should be properly managed. I call it managed because in time and space, there are areas that you can really tap groundwater. Some areas you cannot. But in time, maybe you can pick up now and so on, depending on where you're picking up from the ground, from the shallow or the deep groundwater. But in any case, that's what I mean by properly managed. So that's number one, if you want immediate water supply. But definitely Laguna Lake is a good source of water. I think I've been saying all along, even in the book I mentioned about that because of the inflow from Marikina River diversion through Mangahan floodway during the flood season, we have like exotic water to Laguna Lake coming from Marikina, when before it just go to Pasig River. So that should, but perhaps as far as water quality, tap it on the eastern side of Laguna Lake, the east lobe, rather than the west lobe or the west bay of Laguna Lake. And then, of course, you can always look at the Kaliwa Kanan Agus River system and even go to Pampanga River Basin. It's not so far away. I think Southern California, for instance, picks up a good bulk of its water about 800 miles upstream, north from the Shasta Reservoir. They move it through the Sacramento River and then the California aqueduct. So Pampanga is just a few kilometers away, just like as far as Angat Reservoir, I think, to Metro Manila.
Okay. Thanks for that. I think there are two questions here that are somewhat related, and I'll read them through them both. You can probably answer them at the same time. From Ses Abad, this is a project Iwasto, and he's asking, although optimization and other related studies help us analyze and look for possible water sources, we cannot erase the fact that this change bring cultural, economic, and sociological impacts to the involved area. How are we going to incorporate this to bring sustainable water supply?
Yeah, that's the reason why that I think models or decision support systems, for that matter, are only vehicles to be able to bring in people and to be able to articulate, to be able to express what the physics is trying to say or is saying to the stakeholders or to the different policy actors or the management, the managers. So it should not be considered, or it should not be looked upon as the answer or the God or to dictate your decisions. It has to still go through, because I think the mind, in fact, I have some presentation that we have this individual collective mind, which is a combination of our ability to think from a static point of view, from physical observations, from sympathetic feelings, from a reflective point of view, analytical point of view, and even aesthetic point of view. And then we have a community collective mind. So that's where we need to have to develop a shared vision or to develop consensus build to have consensus building. You have to gather people and talk, and models will just display the physics of what happens. But all these socio-ecologists, hydroecologists, or the eco-hydrologists, they have to transcend their thinking to the point that it becomes transdisciplinary.
So you're saying that all of this have to be incorporated in the analysis as well.
Yeah, the models or the results of optimization should just be an aid or a guide to support how we should manage the system. We still have to have the warm bodies to make decisions, actually.
A follow-up question on that, I think on a similar thread, is that Jason Valdez is asking if the results from the modeling studies, which are based on science, be given more weight than the socio-cultural issues such as ancestral domains and biodiversity.
Not exactly. Unfortunately, I did not put my slides on transdisciplinary approach. But in the transdisciplinary approach, the 4 features. First is that you engage everyone from problem identification, solution knowledge generation, solution generation to generate the solutions, and even implementation. Then you have feedback, monitoring, etc. Number 2 is that you have to work collectively and iteratively. Number 3, I think the first one was engage stakeholders and so on. But the fourth one is that decisions should be on hierarchical basis. First, you make sure that the physics is satisfied. Then you can go to the ecological environmental soundness of the project. And then you go to the economics of it. And then you go to the social, political, and so on. So in other words, why talk about bringing water to this community from this water source, but there is no water? I mean, the water source. So you have to check first the physical premise before you can entertain the ecological and the social equity issue of providing water. So you have to have that hierarchy. So I think, I'm not saying that there should be one priority, but rather every component is important, except that you have to go through this hierarchy. You just start with the physics, otherwise nothing to talk about if there is no water to begin with from the water source.
Yes. Okay, thanks, Glenn. I would ask one more question because I think we're running out of time, but I will probably lump together a common theme from many of these questions, which is something to do with the water quality. So STPs, lack of water treatment, and what can we do to address these issues? For instance, even during this pandemic, where models probably related to virology, public health, and reuse of water will now become very important in light of these issues coming up on the water quality aspect.
Yeah, unfortunately, I'm not so familiar with the water treatment in particular. A lot of my studies were more on water quality on large scale, like pollution, risk of pollution, groundwater, and so on, and then water quality from the point of view of an overall index as the state of the health of the bay, maybe based on some dissolved oxygen and so on. So not quite, unfortunately, I couldn't really say anything about water treatment plants and so on, or water treatment technology for that matter.
Okay. So I think we will entertain one more last question. I think this is has something to do with the future. Uh,
Okay.
how do you see from Alex, this is from Alan Vizcaya, you see the Department of Water being created soon? Is there like light at the end of the tunnel for this one?
Yeah. What happened was that in November 2019, the Congress, after about 3-4 years, actually it started way back in 2012, but I mean 2014, but in November last year, I'm part of this technical working group to consolidate almost 31 separate proposals, but actually they're just maybe similar. I wouldn't say copying, similar. And then you have to consolidate them to come up with one. So that's in Congress. And then the Senate already picked it up. So sometime, I think December, January, we have this technical working group consolidating 8 bills related to the creation of the Department of Water. And then COVID came in. So February, we even had this big meeting in the Senate. So again, I'm part of that to consolidate all those bills because they look similar here and there. They have commonalities, some have new things. But I think the thing there is that the senators, congressmen, they might have. And then what happens that, like for example, the congressional bill now, it is sponsored by 31 congressmen. In the Senate bill, there will be 8 or 9, I think 8. So that was supposedly the state already of the bills. But
Just a matter of waiting, perhaps. Okay, thank you for that. At least something's
okay.
moving along that line. Thank you for those questions and answers. I think although there are some more questions, unfortunately, we have reached the end of our seminar. But we will try to answer those questions by sending you by email. So we'll ask Dr. Tabios to look at them as well.
Okay.
Before we conclude, we would like to thank all who joined us through Zoom and those who followed us live through Facebook. And as a final reminder, if you participated through Zoom and you may want to get a certificate of participation, please take time to answer the short poll that will be flashed right after this webinar. On behalf of our director, Dr. Tan Chuling, and the ICE faculty, we thank you for joining us today, and we hope to see you again in the next presentations of our webinar series as we commemorate 110 years of civil engineering. Please join us in reimagining the future. Register in advance by visiting the official social media accounts. With that, we thank Glenn. Thank you, Glenn.
Thank you very much, Dr. Roy.
We thank the panelists and all who participated in our webinar today. It has been a great afternoon. This is Roy Soriano signing off, and keep safe, everyone. Bye.
So Anju will get out.
Yes.
Yeah. Okay.
Good afternoon, everyone. On behalf of UP Institute of Civil Engineering, I would like to thank you all for joining us in the very first offering of the UPICE webinar series. We are very happy with the audience turnout and the very productive discussion. Hats off, Doc Glenn, UPIC's very own. Congratulations on your book. Thank you to our moderator. Nice to see you also, Dr. Roy. We would also like to recognize our co-presenters, UPERDFI and the Philippine Institute of Civil Engineers. To all the participants in Zoom, again, if you wish to be issued a certificate of attendance, please answer the Zoom poll that will flash in your screens. We'll do our best to issue them within 2 weeks. And also, please watch out for our next webinars. Let's see if we can flash our list. We have a good lineup ahead of us, coming all Fridays of July, 3 p.m. We are looking forward to see you all again soon. So we have topics on construction engineering and management, transportation engineering, and how we adjust the Philippine Building Act of 2020. Again, this is all part of the 110 years anniversary of the Civil Engineering Program of UP. See you all again next Friday. Stay safe, everyone. Thank you.